Hi, and welcome to our second video on meteorological instrumentation. Specifically, we're looking at instrument design and selection. And in this video, we're going to continue talking about characteristics. What we're looking at are terms that we use to describe meteorological instruments. In this video, we're going to talk about repeatability, reproducibility, time response, representativeness, stability, and reliability. Reproducibility means how well or how close repeated measurements of an output show the same value. In other words, if you keep measuring the same, in this case, temperature, if you're measuring the temperature of the air and you measure it several times, the temperature is not changing of the air, and your measurement shows it's not changing, then you say you have good reproducibility, the closeness of agreement among repeated measurements of the output for the same value. Repeatability is similar to reproducibility, but it's over the full range of observations. So in other words, for values, same values at many different points in the range of that instrument, you keep getting the same values, then you say it has good repeatability. Time response is how well or how quickly an instrument responds to the change in the input. How well is the sensor able to measure the change in that meteorological variable? Here we're looking at a change in temperature. How fast does it measure that change in temperature? And that depends on a lot of things. It depends upon what's being measured. Some variables measure a change very rapidly, others change more slowly. And then also it depends upon what type of instrument you're using to measure that. If you're flying through a cloud with an airplane, you have to have a sensor that has a very low time response, very fast, I should say, very fast time response. Because you're moving along, and as the airplane moves, it's traveling over maybe 100 feet per second. And so you want a sensor that can measure its time response less than a second. It would be a very, very quick response. Representativeness means how well an observation from a sensor represents the true value. Sometimes you make measurements and the measurements aren't really worth anything because there are other factors that are obscuring what you want to measure. Let's look at some examples. Let's say you have thermometers and you want to measure the temperature of the air, but you inadvertently leave the thermometers out in the sunlight. Well, what the thermometers are going to be measuring is the solar radiation coming in from the sun and not necessarily the air temperature. So that is an example of poor representativeness. Likewise, a rain gauge. Is it measuring enough of the weather phenomena? Typically with storms that cover a large area, we're saying like a winter storm that dumps a lot of snow. Usually your measurements or your precipitation is pretty uniform over a region, but as you know, with thunderstorms during the springtime or summer, it can be wet across the street and dry in your backyard. So it's not really measuring or sampling the phenomena very well. As we mentioned before, there are problems also with time response when you're flying along. Is the instrument measuring things fast enough? Is it sampling fast enough? And then other phenomena like with radiosondes, if a radioson or balloon goes up through a cloud, do you really want to measure the cloud? You're trying to measure the air and the temperature of the air and the moisture of the air, and not necessarily the cloud. And then, of course, there are other problems with calibration. For example, sometimes radars are not really showing you what's going on because they may not have been calibrated properly. So are those values correct? So as meteorologists, we need to look at the measurements and decide whether those measurements are in fact telling the story or not. So it's up to our intuition to figure out what the instrument is telling us. Stability is the ability of an instrument to retain its calibration over a period of time. And then reliability is a measure of the probability that the instrument will continue to perform within its specifications. So those are some terms that we use when we describe meteorological measurements and instrumentation.